Okay, this is still in chapter 3, and the last few videos really kind of covered the meat of chapter 3, at least in my opinion, which is kind of stoichiometry and taking a chemical equation and being able to make quantitative statements about if you started with so much, how much is created, and so forth. So this last set of videos for chapter 3 is really going to focus on solution chemistry, and it's kind of an intro in a way because we're going to get into much more of this, and of course once we get into organic we're going to get into far more of this. So this is basically about chemical equations that happen in solution, essentially meaning when the reactants are dissolved in a liquid, usually water. So the reason why this is so important is basically all biological systems, or almost all biological systems, take place with where the chemical reactions take place in solution, basically in a water-based solution, which is also known as aqueous solution. Okay, and so you'll see the term aqueous reactants or aqueous chemistry and all that, and it's basically talking about chemical reactions that happen while the reactants itself are dissolved or suspended in solution. Probably dissolved, suspended is probably different. Okay. Anyway, so what I want to kind of cover here, I'm going to kind of piggyback on the last example and talk about a little bit, and this is kind of in preparation for some of the future chapters as well, but kind of talk a little bit about some terms involving solutions, chemical solutions. Okay, so first of all, the most common, or say the most valuable term with respect to solutions is something called molarity. I'm going to use the whiteboard a little bit today. Where's my pen? I think I'd actually find these before recording. Okay, molarity. The term molarity refers to a concentration kind of term, meaning it's a term that reflects how much of something is dissolved in solution, and it's basically the units of measurement of molarity are typically moles per liter. Okay, and so, for example, a 2.0 molarity, by the way, the symbol for molarity is usually M. 2.0 molarity solution of sodium chloride is essentially saying that there are 2 moles of sodium chloride for each liter, 1 liter of solution. Okay. Now we know how to convert moles of sodium chloride to grams of sodium chloride, right? So this molarity is kind of you can see is kind of a term that refers to how concentrated is the solution, in this case the salt solution, how concentrated is the solution. Let's see. Now, a lot of times you don't, and I'm not going to bother to do the math here. Well, maybe I should. Sodium chloride is, again, we can convert this to a different term. Maybe I will start there. Sodium is 23 and chlorine is 35.5. 23, chlorine 35.5. So another form, another measurement, or another unit of measurement in terms of concentration would be, instead of molarity, it would be basically mass concentration. So, for example, we started with with molarity of sodium chloride of 2, like this. We could easily convert this 2 moles per liter times some number of grams per mole of sodium chloride, which, again, you remember before we would do the molar mass of sodium chloride is essentially, I'm going to round this up. Well, I guess I shouldn't. 50. I'll call this 59. Okay. And so that, when you multiply it out, turns out to be 118 grams of sodium chloride per liter of solution. That's what molarity of 2 is. So a lot of times you'll see concentration expressed in terms of grams as well, in terms of weight, and that's called a mass percentage or a mass concentration. Molarity is a lot simpler to use, especially when talking about chemical reactions, and you'll see that in an example that I have coming up. Another concentration term that I just want to throw out here because it's fairly common, and it's because I'm going to use it in an example, probably in the next video, is I'm going to erase this now. Is a concentration term which expresses the amount of a quantity by volume divided by the volume of the solution. Okay, and a classic case of this is in spirits. If you can see this, it says, here's a nice little handcrafted vodka. It says 40% alcohol by volume. What that essentially is saying is that for every liter of solution, you have 0.4 liters of alcohol, good old ethanol, C2H6O, divided by for every liter of solution, meaning in this case vodka. Okay, so if we were to pose a problem, which I will solve in the next video. The problem is, imagine that we have some really strong vodka that we can burn. We can pour it on a dessert and set it on fire, or we can just actually burn it in a controlled fashion in the lab. If we were to burn a certain amount of alcohol that is dissolved in water, basically it's mixed with water, and we'd ask ourselves how much carbon dioxide is produced. Remember, this is kind of piggybacking off of the last video that I did earlier, where I basically said, imagine you had 230 grams of pure ethanol. Well, we know how to do all that with the stoichiometry that we did the last time. But what instead of the problem was posed, what if you actually had, I don't know, a half a liter of really strong vodka? Same question could be posed: how much carbon dioxide is produced when you burn it? Or even better is how much, assuming that all of it burns away completely, how much water is produced? Now, if you remember, the chemical reaction produces some water, but if the vodka has water in it already and it boils off also, then there's going to be water produced, boiled from the burning of the strong vodka. Okay, that's going to be the next problem that we solve, and we're going to kind of make use of the volume percentage of alcohol, which is just, in some ways, is the least convenient way of expressing concentration. But I'm going to use this to go through a calculation that shows how to take inconvenient concentrations like volume percentage, turn them into molarity percentages, and then actually do the stoichiometry equation, the equation kind of we did before in terms of burning ethanol, and then finally take into account the fact that the solvent, essentially the stuff that the alcohol is dissolved in, water in this case, the solvent itself boils away. Okay, so I'm going to end this one and we'll do one more.